Today we'll look at a few more properties of logarithms beyond the ones that we've discussed previously. If you remember, we see a few of those here. For any base b, we know that the log of 1 is equal to 0. Again, remember that's because any number raised to the power of 0 is equal to 1, assuming that the base is not 0. And a few other properties here too. Remember the log of b itself is equal to 1. We can also compose log functions and exponential functions to leave us back with just the identity x. So the log of b to the x or b to the log of x, both of those are just equal to x. Today, though, we'll try a few new ones. We'll take a look at this product property, which says that if we have a log of two numbers or two quantities being multiplied, we can separate that into two separate logs with the same base using addition. The quotient property tells us the same thing, except instead of multiplying two pieces on the inside of a log, we've got a division there, which results in a subtraction when we separate it into two different logs. Both of these are true because logs work like exponents, and these sort of mirror the exponential properties that we're used to seeing. Thirdly, there's the power property, which again sort of follows from exponential properties. If you have x to the power of y inside of a logarithm, we know that we can actually take that exponent of y and write it in front of the logarithm itself, and so that we have something like y times the log base b of x. So a couple quick examples to see sort of how that works. We can do two things really with this. We can take a logarithm that looks pretty complicated, like this one, the log base 4 of 64j divided by k squared times l. We can take that one and expand it out as much as possible. So we can use those properties to sort of separate this apart. In general, if you see a fraction or a division in there, it's best to separate that first using the quotient property. So we would take that one log and separate it into two using a subtraction. We would take the log of the numerator and subtract the log of the denominator from that. This way you've got two logs. Each of those may have multiplications in there and or some powers, but this separation helps us to sort of piece those apart first. Next, we could take each of those logs, since there is a multiplication. For the first one, we have 64 times j still, so we could separate that one into two. Also, we can separate this k squared l into two pieces as well. Notice we've got now log base 4 of 64 plus log base 4 of j, separating the first term. And then for the second log being separated, notice I put parentheses around these, right? Because if we're separating using the product property using multiplication, then we can write it with an addition. We can say log of k squared plus log of l, again, all assuming base 4. But that entire quantity is being subtracted. So we make sure to do that using parentheses, and we'll have to distribute that negative throughout. So we can step that forward a little bit more. We can distribute that negative through. And then finally, we've got something that looks like this. Now, you don't necessarily have to do this, but we could, since log base 4 of 64 is just a number, unlike the others which have variables. We could simplify that. Remember, this means essentially 4 to which power is equal to 64, and we know that that would actually be 3, because 4 cubed is 64. Also, one thing that we didn't mention is that sort of going from this step to the last one, we did use that power property too, right? We can take that exponent of 2 and bring it down in front of the log, so multiply the log of k by 2. Let's take a look at one more. The goal in this next one, though, is to sort of do the opposite thing. We can combine those back together. We can rewrite it using a single logarithm instead. So picture this as going in reverse from what we've done before. We can sort of do those opposite steps. In general, this time, those powers are good things to simplify first. So we can rewrite that first log. Again, this is the natural log, so we assume the base e. We can write this as the log of a cubed, and we can write the third one there as the log of the square root of c instead of 1/2, because remember, an exponent of 1/2 means the same thing as a square root. Notice I did one other thing here too. I rearranged the terms a bit. So I put the positive ones in front and the negative ones towards the end. So the log of a cubed plus log d are the positive terms. And then since there are minuses in front of the middle two, those are negative. So we write those last. And that's just to sort of go in reverse of what we did before. Remember, since those are being subtracted, we could factor out a negative. In the long run, we know that those two terms are going to end up with pieces of the denominator once we've combined it all together. But if we're trying to strictly follow the steps, we can see sort of how this works. We can factor out that negative, and we're left with the log of b plus the log of root c on the inside. The reason we would do that is so now we can use the multiplication, the product property, to combine the first two logs together and combine the stuff inside the parentheses as well. So we end up with two logs. We have the log of a cubed times d, and we have the log of b times the square root of c, and those are still being subtracted. So we can use one final step to use the quotient property to combine those two logs together with the division on the inside. So we'd end up with one single log, the log of a cubed d, divided by b times the square root of c.